Hi students, now we are going to solve some problems in Fourier transform. So before solving these problems, I need to recall that transform, that is transform for different signal. Okay, so these are all the things what we have studied so far. So e power minus bt u of t is 1 by b plus j ohm. So similarly here for a rectangular pulse, it is a sync pulse in frequency domain. Impulse signal, it is 1. For a sync pulse, it is a rectangular pulse. For 1, that is a DC signal, it is 2 pi into del of ohm. For e power j ohm naught t, it is 2 pi del of ohm minus ohm naught. E power minus j ohm naught t, it is 2 pi into del of ohm plus ohm naught. Sin ohm naught t, pi by j del of ohm minus ohm naught minus del of ohm plus ohm naught. And cos ohm naught t, pi into del of ohm minus ohm naught plus del of ohm plus ohm naught. Next for del of t minus t naught, it is e power minus j omega t naught. Then for a signum of t, it is 2 by j omega. Gaussian, it is a Gaussian. So these are all the frequently used terms, functions, so that we can easily apply directly the formulas for finding the inverse Fourier transform. Now we will see some problems related to this. Okay, so here see, find the inverse Fourier transform of x of j ohm, where x of j ohm is given. Okay, now when you correlate with this already find out formula, so you this is 5 by 1 plus j ohm is somewhat resemblant to 1 by b plus j ohm, right? So here instead of b you are having 1 here, and also here instead of b you are having 0.98. So directly you can apply formulas, otherwise you can apply the inverse Fourier transform formula. So here see, in order to find the inverse formula, we have to use this formula. Just we need to find x of t. While applying these things, you need to perform integration, then you have to apply limit. So it is somewhat complex process. So what we can do is, we are going to use these formulas. We are going to use these formulas for simplifying the results. Okay, now see here, I am going to apply these formulas. So x of j ohm is equal to 5 by 1 plus j ohm. So what you need to rewrite is e power minus bt u of t formula is, that is transform is 1 by b plus j ohm. Okay, so now we have to write applying this x of t equal to, here 5 is a constant, so there is no need to do anything. 5, so e power minus bt u of t, instead of b you are having 1, so e power minus t into u of t minus 2.5 is also a constant. Instead of b here you are having e power minus 0.98 t into u of t. Okay, so this is what your answer, x of t equal to 5 e power minus t u of t minus 2.5 e power minus 0.90 into u of t. Okay, without applying this formula, using the direct formula, we have obtained the results. Now see this formula, now see this problem, find the Fourier transform of y of t is equal to t into x of t, where x of t equal to e power minus bt into u of t. Okay, now here if we want to find y of t, what we need to do, we need to perform t into here we have to substitute this value here, and we have to use this formula to find out this. Since in integration it's involved integration, it involves complex steps. So what we can do is, we can see whether we can use any of the property related to it. Okay, so we know that if you have t into something, that is whether we need to check whether you are having any property related to t into x of t. Now see here, we are having one property known as free differentiation in frequency domain. What we are having is minus j t into x of t equal to d by d ohm x of j ohm. So here by using this property, what I am going to write is minus jt, this transformation is d by d ohm into x of j ohm, right? Now what we are having, only we are having t, so this can be written as t into x of t, 1 divided by minus j d by d ohm into x of j ohm. We can modify this, so taking j to the numerator, it will become minus j, so minus into minus will become plus, so j into d by d ohm into x of j ohm. So here this is what the t into x of t. Now here what we can do is, so by applying this formula, so what we need is, in order to find t into x of t, what we need is, we need x of j ohm, then we need to differentiate with respect to d ohm. That's the thing, you need to do it. Okay, so what I am going to do is here, applying this property, right? E power minus bt u of t equal to 1 by 1 plus b 1 by 1 divided by b plus j ohm. So here x of j ohm for this formula is, x of j ohm is equal to 1 by b plus j ohm. Okay, so here now apply this here, j d by d ohm into 1 by b plus j ohm. Okay, now this is what the formula here you are having. Okay, now when you differentiate with this, how we can write this? I need to differentiate this. I am performing differentiation here, d by d ohm into b plus j ohm whole power minus 1. This can be written like this. So when I perform a differentiation, so what I will get, b plus j ohm minus 1 into, what is the coefficient of differentiating with respect to j? So here I am having j, so this can be written as j by b plus j ohm the whole square. Okay, so here when I substitute it, what I will get? Okay, so here, and also you need to multiply here the coefficient, right? Okay, so what you need, you will get is, you will get it as minus j. Okay, so what you will get is, here you will get j, so minus j divided by b plus j ohm the whole square. So j square minus 1, here it is minus plus 1, so divided by 1 divided by 1 plus here j ohm the whole square. So this is the answer for this. So by applying the property itself, we can obtain the answer. So now see the third problem. We need to find the Fourier transform of this signal y of t equal to d by dt u of t minus 3 minus u of t plus 3. Either you can apply differentiation property here. Otherwise what we can do is, we can simplify the step. We know that when you differentiate a unit step signal, what you will get? You will get an impulse, right? So d by dt into u of t, when you differentiate this, it will result in del of t, impulse signal. We have already studied this. So applying this, so what you will get is, you will get an impulse at del of t minus 3, and you will get a impulse at del of t plus 3. Now for better understanding, draw this diagram. So this is what u of t minus 3, and this is what u of t plus 3. Okay, since it is minus, I have drawn, put minus sign here. Okay, now see, when you differentiate this, what you will get? You will get an impulse, right? So here what I am getting is, here I have chosen minus, so here it is minus, right? So y of t, now you are getting del of t minus 3 minus del of t plus 3. So you know that there is a one formula, there is a transform for this. You del of t minus t naught can be written as e power j my omega t naught. Applying this formula, this y of t can be written as, that is by applying that is Fourier transform, this will become y of j ohm. This, when applying this formula, it will become e power minus, instead of t naught I am having 3, so 3 ohm. Sorry, here it is, we will represent this by ohm, right? So here it is 3 ohm t naught, and minus e power minus plus j 3 ohm. Okay, now this is what the resultant for this e power del of t minus t naught is e power minus j ohm t naught. Here t naught is what is T naught? T naught is 3. So here you will get e power minus j 3 ohm minus e power plus j 3 ohm. So here another thing I have forgot to tell is here. So this is what your del of 3, right? So here see, if I, this is what u of t minus 3. So when I, for simplification, I can I have drawn like this. Okay, now here see this one. So here it is u of t minus 3 and here it is u of t minus 3, sorry, t plus 3. Okay, so here what I can do is, here you can have an, you, when you differentiate this signal, what you will get it, you will get an impulse here, right? Here you will have an impulse. Okay, because both are, here it is a decreasing function, right? So what you will have, you will get a minus impulse. Here it is an increasing function, so you will have a plus impulse. Okay, now when you apply this differentiation, what you will get is, already minus is there, so you will get plus. Understood why I have changed? Before that I have directly drawn this. Okay, so now it is u of t plus 3. Now it is u of t plus 3 will be like this. Now here, since it is a down pulse, that is it is decreasing, here it is increasing towards, so here you will have a one pulse at the positive, here you will have a negative pulse. So already here minus is there, so here I am changing this to plus. Okay, so now here you will have plus. Understand why I have, first I have drawn like this, because we are different, we have drawing this structure. Then if you want to perform differentiation, what we have to do is, we have to do it in this manner. Otherwise you can, if you want to do using this, what you will get is, so this is what u of t minus 3 minus u of t plus 3. So when I perform differentiation for this, the apply differentiation, this is an increasing function. So what you will get, you will get an impulse. So this is also an increasing function, you will get an impulse. So in this case you have to add these two signals. Whether you understand the difference, either you can directly do for this or you can directly do for this, anyhow you are going to get the same results. So this, for this one you will get it. So when you apply in this formula, there is a minus, so what you will get is, you will get an impulse like this. Okay, so y of j ohm is equal to e power minus j 3 ohm plus e power j 3 ohm, which is equal to 2 cos 3 ohm. So this is your y of j ohm. Okay, so you will get y of t is equal to at minus 3 at 3. Okay, so here this is what your y of t. So this is what your y of t. And after applying this y of t, you are getting y of j ohm is equal to 2 cos 3 ohm. Now see this problem, x of t is equal to signum of t. You need to compute signum of 3t. Okay, so here see, you can use scaling property for this. So that is scaling property is x of at transform is 1 by a x of j ohm by a. Okay, now here what we are having, instead of a I am having 3, so 3t, so 1 by 3 into x of j ohm by 3. So I need to find out first x of j ohm. Okay, so here Fourier transform of a signum of t is equal to, we have already find out this, the Fourier transform of a signum of t is 2 by j ohm, 2 by j ohm, so it is 2 by j ohm. Okay, now x of 3t 1 by 3 x of j ohm by 3. So what is the meaning is, wherever you are having j ohm, there you need to replace j ohm by 3. Okay, so when I apply this, what I will get is, I will get 1 by 3 2 by j ohm by 3. Okay, so this can be written as 3 will go into the numerator and you will get 2 by j ohm. Okay, so here what is the meaning of this? If you perform scaling, the signum function the same, you will get it 2 by j ohm. So when you this 3 go into the numerator, this will get cancelled, you will get 2 by j ohm. So thus by applying this scaling property you can find out the signum of 3t. Similarly, for this problem, find x of minus t. So here it is x of minus t. You know that it is a time reversal property, that is it is x of minus j ohm. So what you need to do is you need to find x of minus t. So x of minus t, which is equal to signum of minus t. So here applying this reversal property, here it is reversal property is x of minus t result in x of minus j ohm. So x of minus j ohm for this one is, so the signum of that is the Fourier transform of signum of t is equal to 2 by j ohm. So here you need to find x of minus j ohm. So wherever you are having j ohm, you need to replace by minus j ohm. So signum of, that is signum of minus t is nothing but 2 by minus j ohm. So like that you need to find it out. Now see the next one, x of t is equal to cos ohm naught t, where x of t minus t naught is equal to cos ohm naught t minus t naught. Okay, now here this is, you know that this is a time shifting property. You know that x of t minus t naught, when you apply this property you will get e power minus j ohm t naught into x of j ohm. Okay, now applying this property, so what you will get is cos of ohm naught t minus t naught. So this is, instead of this x of t minus t naught I am having, so first we need to find x of j ohm. So a cos ohm naught t, if Fourier transform is, when you need to apply the Fourier transform for this, so it is pi into del of ohm minus ohm naught plus del of ohm plus ohm naught. This is the formula for this. Okay, so cos ohm naught t, so when you apply t minus t naught, so what you will get is cos of ohm naught t minus t naught. So what you will get is, you will get e power minus j, instead of ohm here I am having ohm naught into t naught. Here t naught, what I am having, I am having t naught itself. So it is t naught e power minus j t naught into pi del of ohm minus ohm naught plus del of ohm plus ohm naught. So this is what the actual formula. In addition to this I am having e power minus j ohm t naught. So like that you have to apply the properties and you have to simplify it. Okay, next problem is x1 of t is given, x2 of t is given. You need to perform convolution by convolution property. So that is the convolution of the two signal in a time domain is equivalent to the multiplication of the two signal in frequency domain. So it is x1 of j ohm into x2 of j ohm, that is multiplication of the signal in frequency domain. So here what we need to do is, in order to find this, what you need to know, you need to know x1 of j ohm. So here it is x1 of t, x1 of t, it is Fourier transform is x1 of j ohm. So you know that a Fourier transform of u of t is what? It is u of t is it is what is the Fourier transform of u of t? It is the, that is u of t is 1. So here what you will get is, for 1 it is 2 pi into del of ohm, and x2 of j ohm, it is a signum function, it is 2 by j ohm. Okay, so here when you want to find x1 of t convolution x2 of t, so what you will get is, here you will get 2 pi into del of ohm into 2 divided by j ohm. So this is what your answer you will get for this. Similarly, we can solve any problem using these properties, and you can simplify this complexity involved in the computation. Okay, hope you have understand this concept. I think all these concepts are performed using these properties. Okay, so I think hope you have understand these concepts. Okay, in the next class we will see the that is the we will discuss about the LTI continuous time system characterization by linear constant coefficient differential equations. Okay, thank you.